You're welcome to this. We're looking at kinematics, okay? A particle moving in a straight line, okay? We're going to be looking at the derivation of the equation of a straight line, derivations of kinematic equation, and then after that, we'll take a series of questions. Let's start from acceleration. Acceleration is a change in velocity over time. Okay, as you're coming in, just begin to say I. Okay, just begin to say I. Acceleration is a change in velocity, and this will be v minus u over t. Okay, and make this v as a subject, and that will be equal to what? V minus u equal to what? At. Move this u to the other side, then we have v equal to what? U plus at. Okay, and that gives us the first equation of motion, where your v is the final velocity, your u is the initial velocity, your u is the initial velocity, a is the acceleration, a is the acceleration, okay, and t is what? Is the time. Okay, so we've gotten the first equation of motion. Okay, then you have to note that acceleration is a vector quantity. Acceleration is a vector quantity, and it has the units. Acceleration is measured in meter per second square. Acceleration is measured in meter per second square. Let's quickly get the second equation. We can have displacement equal to what? Average velocity times what? Times time. Average velocity times time. And that will be equal to what? Average velocity will be equal to u plus v over q. That's the average velocity times what? Times t. Okay? That's our second equation, where your u is the initial velocity, your v is the final, your t is the time. Okay, we can work on this equation. We can plug in this first equation into this equation and derive another equation. Okay, so plug in equation 1 into this place. So that will be equal to what? U plus your v is what? Is u plus at over 2. Okay, times what? Times t. Okay, so if you do that, we're going to have u plus u, that's 2u, times t, that's that 2ut plus 80 times that t, that's a plus 80 square, okay, over 2. And then do the algebra, which implies this one over 2. Okay, so we have this x equal to ut plus what? Plus half at squared. So that give us the second equation of motion. We have the first one as u equal to what? U plus at. We have the second equation as average velocity times time, u plus v over 2 times t, and we have the third equation as displacement equal to what? Ut plus half at squared. V equal to u plus at. Okay, to get another equation. Okay, how do we do that? Square this one, square this side, square both sides of the equation. Square this, square this. I mean this equation, v equal to u plus at. Square both sides of the equation. Okay, so if you do that, you're going to have v squared equal to, do the expansion of this one, and that will be u squared plus 2uat. Okay, and finally plus what? Plus at squared. Just do the normal expansion for this, then you have this. So if you do that, you're going to have ut plus this 2, because 2 is outside, that will generate over 2 here. And then this is a square. 1 is already outside, so you have 1 here and what and t squared. Okay, and don't forget from this equation, x equal to ut plus what, half a t squared. So substitute that into the above equation. So we have u squared plus 2ax. So that is another equation for motion. Okay, so for summary, for those equations, we're able to prove that v is equal to what, u plus at. That's one. We are also another equation. We were able to generate this one. That's another equation. Okay, and we're also able to generate v squared equal to what, u squared plus 2ax plus 2ax. Okay, so these are the equation we have. I think I see another one. This one also, x equal to ut plus half at squared. So these are the equations we are going to be using. A particle is moving in a straight line with constant acceleration of 3 meters per second squared. At time t equal to 0, the speed of the particle is 2 meters per second. Okay, find the speed of the particle at time t equal to 6 seconds. So when you see a question like this, the first thing to do is to begin to write your parameters. So state your parameters. That's the first thing to do. So let's look at the information we have. Acceleration is what? Acceleration is 3 meters per second square. Okay. At time t equal to 0, the speed of the particle is 2 meters per second. Okay, that will be the initial speed at t equal to 0. The speed is what? The speed is 2 meters per second. Okay. Then again, we want to find the speed of the particle when t at time t equal to 6 seconds. So the final velocity we don't know, but t is what? T is at 6 seconds. So we are going to look at the appropriate equation, okay, to use. Okay, we can look at this equation and begin to ask ourselves, is this applicable? Let's check that. We have the t, we have the acceleration, we have the initial velocity, but we don't have the final velocity. So this would be appropriate equation to use. Let's check another one again. If you look at this one, can we use this equation? Let's check that. Can we use that? Okay. We have u, we have t, okay, we have acceleration, but we don't have, we have t, okay. We can use this equation, but the question is not asking for distance, okay. The question is not asking for distance. The question is asking us to get what? To get the final velocity. So this equation is not applicable. It's not applicable. Okay. Can we also use this one also? U plus v. This one also, we are not told to find the distance, so this one also is not applicable. Okay, actually all the parameters is given. We have the initial velocity, we have the final velocity, we have the time also. Okay, but we are not told to get what? To get a distance. So that makes this equation unapplicable. On what? Unapplicable. Okay, then can you also check this one also? V squared equal to u squared plus 2ax. Can we use that? We need the final velocity, we have the acceleration, we have the u, okay? We are looking for the final velocity, but we don't have the distance in the parameters. So this equation also is not applicable. So this first equation is the equation we are going to use. And if we check the parameters, we have 4 parameters in this equation. 3 of the parameters are given, then we can get the fourth parameters. As you're just coming in, just need to say I as you're coming in. And if you are new on this channel, the best thing to do is to subscribe right now. I've been told the answer. The answer has been given from the comment section. Let's quickly confirm that. Let's confirm that. So u is what? Your u is what? 2 plus the acceleration is 3. The time is 6, and that will be 2. That will be 2 plus 18, and that will be equal to what? 20. Okay. From the comment section, I can see 20, but you need to indicate the units. Unit is very crucial in physics. If you leave it as 20, we'll wrong it for you. Unit is very, very important. You must indicate the units, because if you don't put the unit there, we will not know what the 20 stand for. We won't know what that 20 stand for. This is physics. The unit must accompany the value. Okay, the unit must accompany the value. A car is approaching traffic lights. The car is traveling with speed 10 meters per second. Okay, the car is traveling with speed 10 meters per second. That's the initial, that's u. That's a 10 meters per second. Okay, the driver applies the brake. The driver applies the brake. Okay, and the car comes to rest. Underline that statement. Underline that statement. When the body comes to rest, your final velocity will be equal to 0. When an object comes to rest, the final velocity will be 0 meter per seconds with constant deceleration. Okay, but we're not given the value. We were told constant deceleration in 16 seconds. So the t time is 16 seconds. Okay, modeling the car as a particle. Modeling the car as a particle. Find the deceleration of the car. Find the deceleration of the car. Acceleration is what we are looking for, but we expect our value to be a negative, because deceleration implies, okay, deceleration is negative acceleration. Deceleration is what? A negative acceleration. So automatically our value for acceleration will be negative value. Okay, so let's now look for the appropriate equations to use, appropriate kinematic equations to use. Okay, we have u, we have v, we have the t. Okay, so we're going to try this one. Let's try this one. We know the time. Acceleration is what we are looking for. We know the u, and we know the final velocity. We know the final velocity. Begin to plug in those parameters. So your v is 0, your u is what? 10. Your acceleration we don't know, but the t is 16. Okay, so move this 10 to the other side, and that will be minus 10 equal to what? Equal to 16 a, and make a as the subject, and that will be minus 10 over 16. Minus 10 over 16. Okay, we can then that will be 5. That will be 8. That's a minus 5/8 meter per second square. Okay, that's the value which will be equal to check your calculator. That's minus 5/8 for the acceleration. The negative shows that the particle is what is decelerating. Okay, deceleration is negative a value of acceleration. Okay, acceleration is what minus 5/8. That shows that the body is what decelerating. Okay, so that's that about deceleration of the car. Please, as you're coming in, just begin to say I. We still have a lot of questions to look into. Okay, begin to say I. Put your answer in the comment section for that question. From point A to point B with constant acceleration, the particle passes A with speed 2.4 meter per second. The particle passes B with speed 8 meter per second. 5 seconds after it passes A, find the distance between A and B. Find the distance between A and B. Okay, the distance we don't know. That's what we are looking for. Okay, those 2 points it passes. The first one will be the initial. That's the first place it passes. U is what? U is at 2.4. Okay, V is what? Okay, the second point, which is what? Which is 8 meter per second. Okay, and then T is what? 5 seconds. Okay, so use this formula and put your answer in the comment section. Use this formula, put your answer in the comment section. We have a cyclist is moving along a straight road from A to B with constant acceleration of 0.5. So acceleration is what? 0.5 meter per second square. Okay, a speed at A is 3 meter per second. That will be U, initial speed, which is 3 meter per second. And it takes R 12 seconds. So T is what? Is 12 seconds to cycle from A to B. Find A as speed at B. Okay, so the speed at A, that was the starting point. That's the initial speed. So the speed at B, that will be final velocity, which we don't know. The speed at A is the initial velocity, while the speed at B is the final velocity. Okay, so we can call this one U subscript A. You can call this one U subscript B. Okay, so what we're going to do is to look for the relevant equation, okay, of motion. Okay, let's check this one. V equal to U plus AT. Okay, we have acceleration, we have the time, okay, we have the U, but we don't know what, we don't know the final velocity. So this will be the velocity at point B. Then begin to make your substitution. Your U is what? 0.5 plus acceleration is 3. The time is what? 12. Okay, acceleration is 0.5. Your acceleration is 0.5. Your U is 3. Your V we don't know, but time is what? 12. So if you do that, this will be 36 plus 0.5. So that will be 36.5 meter per second for the final velocity. For the final velocity at point B. Okay, as you're coming in, just begin to say I. As you're coming in, just begin to say I. As you are coming in, just begin to say I. Okay, then the distance from A to B. The distance from A to B, we can use this equation U plus V over 2 times t. Okay, you can use that equation. We can as well use this equation also to get the distance. You can use this equation also. You get the same answer. You can use that equation ut plus half at squared. You get the same answer. So this is going to be what? Your u is what? Your u is my u is speed at a is 3. Let's correct this one. U is 3. U is 3 here, not 0.5. U is 3 in this place. Okay. Acceleration here is 0.5. Acceleration here is 0.5. Okay. So your answer will be 6 plus 3. Okay. That will be 9. So that will be 9 in this place. 9 meter per seconds. 9 meter per seconds. Okay. Okay, let me repeat that. The substitution, your u is 3 meter per seconds. Your acceleration is 0.5. Your time is 12. So this will be 6 plus 3. That's 9 meter per seconds. And then the b part, for the distance, you can use this equation, u plus v over 2 times t. You can as well try the equation also. Ut plus half at squared. You're going to get the same answer. So that will be equal to what? My u is what? My u is 3. My v is 9 over 2, and then times what? Times 12. And that will be equal to 3 plus 9, that's 12. 2 here 1, 2 here 6. So times 6. So that's giving us what? That's giving us 72 meter. 72 meter. Okay, 72 meter. So that starts on that question. Begin to give the videos a thumbs up. Begin to give the videos a thumbs up as they're coming in. Begin to give the videos a thumbs up. Okay, share the links across a different platform. Okay, and if you're yet to subscribe, please do so right now. Okay, we have this question. A particle moves in a straight line from A to point B with a constant deceleration 1.2 meter per second squared. 1.2 meter per second squared. Okay, the particle takes 6 seconds to move from A to B. The particle takes 6 seconds to move from A to B. The speed of the particle at B is what? Is 2 meters per second. And the direction of the particle has not changed. The direction of the particle has not changed. Okay, find A, the speed of the particle at A. B, the distance from A to B. Okay, so this is what we have. Okay, the first thing to do is to begin to state the parameters. Begin to state the given parameters. We're told the acceleration is 1.2 meter per second squared. So A minus A is what we call deceleration. Minus A, negative acceleration, is called what? Deceleration. And that's 1.2 meter per second squared. Okay, and we can write this as what? As A equal to what? Minus 1.2 meter per second squared. Okay, just multiply this by minus 1 by minus 1. Then you have acceleration equal to what? Minus 1.2. Okay, negative acceleration is called deceleration. Negative acceleration is called deceleration. Okay, begin to share the links of this video across your different platform. Okay, share the links, call your friends to join this live section. Okay, so that starts on that. Then the particle, it takes 6 seconds. So t t is equal to 6 seconds. Okay, to move from A to B, the speed of the particle at B is 2. So the speed at A, we are not told. At A, that will be u. That will be initial velocity, which we don't know. But we are given the final velocity at point B. We're given the speed at B. Okay, at A will be your initial, at B will be your final velocity, which is equal to 2 meter per seconds. Okay, and we are told to find the speed at A. We're told to find the speed at A. So what we are going to do is to look at the appropriate equation. Okay, we can try this one. Let's see that. We're given u is unknown. We don't know u, but we know A, we know t, and we know v. So this is very good equation to use. So begin to make your substitution. V will be equal to what? V is a 2. Okay, your u, okay, we don't know, but we know the acceleration as minus 1.2 times what? Times 6. Okay, then that will be equal to 2 plus, move this one to the other side, the minus to the other side. That's a plus 7.2. 1.2 times 6, that will give you 7.2. Okay, equal to what? Equal to u a, and that's what? That's equal to 9.2 meter per seconds. 9.2 meter per seconds. That is the acceleration at point A, which is the initial velocity. Then we can get the distance. We can get the distance from point A to B, and we can use this equation. The distance, we can use this equation, u plus v over 2 times what? Times t. Okay, make a substitution. Your u is what? Your u is 9.2 plus your v is what? Your v is 2 over 2 times what? Times t. Okay, my t is 6. My 6, that's 6, and that will be equal to what? That will be equal to 9.4. That will be equal to 11.2. 11.2 times 3. 2 here 1, 2 here 3. So times 3, and that's giving us 33.6 meter. A cyclist travels with constant acceleration. Okay, with constant acceleration. Acceleration is x meter per second squared in a straight line from rest to what? To 5 meter per second. So if it's starting from rest, that means from rest to 5 meter per second. From rest means initial velocity is 0. Okay, initial velocity is 0. When the body is starting from rest, it implies that that body initial is what? Is 0 meter per second. Okay, and then to what? To 5 meter per second. Okay, to 5 meter per second. So v is what? V is 5 meter per second. Okay, and t is what? And t is what? T is 20 seconds. So let's finish. Let's work on this. Okay, let's work on this and get the. Because we are told to find the values of x, and then the total distance she traveled. The total distance traveled. Okay, so what we are going to do now is to find the acceleration, which will be equal to this equation. You can use this equation. Okay, the v is 5. V is 5. Okay, initial velocity is 0. Acceleration is what? Is x. Times what? My t is what? 20. Okay, so I can get the value of my x, which will be equal to what? 5 over 20. Okay, and that will be equal to what? 1 over 4. and that will be equal to 0.25 meter per second square. That's for the acceleration. Okay, so we've gotten the acceleration now. Then we can get the distance. Okay, we can get the distance. We're going to get the distance. Okay, two things we're going to do when it's accelerating and when it's decelerating. Okay, let's get the distance when accelerating. The second one, the distance when accelerating. Distance when accelerating. We can use we have u, we have v. Okay, so we can use this equation, u plus v over 2 times t. My u is what? 0 plus v is what? 5 over 2. My t is what? My t is 20. So that will give me 50 meter while accelerating. Okay, that's the distance, which is 50 meter while accelerating. That's 50 meter while accelerating. You're welcome. Okay, if you're yet to subscribe, please do so now and begin to share the links across your different platforms. Okay, call your friends also to join us for this live section. Begin to say I as you are coming in. Begin to say I as you are coming in. So we've got the distance while accelerating. We're going to get the distance also while decelerating. And when we now do that, we now find the total distance now. Okay, and that will be distance when it's accelerating plus distance when it is decelerating. Okay, so let's go on. We've done this one. Then let's continue. She then decelerates. Okay, we're going to do that part now. She then decelerates from 5 meter per second to rest with constant deceleration of this value. Okay. So when decelerating, why decelerating? Why decelerating? We have from 5 meter per second, u is 5 meter per second to rest. V is what? V is 0. Why decelerating? With constant deceleration, acceleration is what? That will be minus the constant deceleration of half x meter per second square. That's half times the x. We have the value now, which is 0.25 times 0.25. Okay, and that will give us if you do that, we're going to have 0.125 meter per second square for the acceleration. Don't forget the minus because it's decelerating. Okay, and then we can now find the distance in these. Okay, if you want to get the distance, can we go on with the distance? Distance we can use u plus v over 2 times what? Times t. But that t, we don't know that t. So we need to find that t first before we can what? Before we can get the distance. We need to get the time when it's decelerating. We need to get the distance, the time when it is decelerating. Okay, so let's see the appropriate equations to use when it is decelerating. We can use this one. We have the v, we have the u plus at. So let's get the t. The v is 0, the u is 5, and then plus acceleration is what? Minus 0.125 times, we don't know the t. That's what we are looking for. So you can make your t the subject. You can make your t the subject. Okay, make your t the subject. Make your t the subject. Sorry for cleaning. So if you make your t the subject, that will be equal to t equal to 5 over 0.125. Okay, take your calculator and let's get the value. I think that will give you 40 seconds. That will give you 40 seconds. Then after that, then you can now get the distance. You can come back here and get the distance. So the distance will be equal to what? U is what? 5. V is what? 0 over 2 times what? Times 20. Okay, and that would what? Is that the case? Let's check this one. Let's check the time here. Okay, this is 40, not 20. So that would be 2 here 1, 2 here 20. 20 times 5, that's what? That's 100 meter. Okay, so then we can now get the total distance she traveled. Total distance she traveled. We can get that from that. Okay, so let's make the final conclusion. So total distance travel, total distance, okay, is going to be equal to what? When is accelerating, we have 50 meter. When it's decelerating, we have 100 meter. So the total distance is equal to what? 150 meter. And that ends the questions. That ends the question. Find the distance when it's accelerating, okay, and then find the time also when it's accelerating, okay. When it's accelerating also, get the time at that point, get the distance, okay. Then you can add the distance, the two distances together. Yeah, a particle is moving with constant acceleration in a straight line. It passes through 3 points, A, B, and C, respectively. The time taken to move from A to B is T1 seconds. And the time taken to move from B to C is T2 seconds. Show that T1 over T2 is equal to 2 over 3. Okay? So what we're going to do, the first thing we're going to do, we're going to start from this statement from A to B. From A to B, okay? Let's see this equation. From A to B, look at what we are given. We're given 20, 30, and 45. So from A to B, this from A to B, final will be 30. We're going to have 30. Initial will be what? 20 plus. Acceleration is constant, it's not changing. Acceleration is A and what? And T1. T1 from what? From A to B. Okay, then we can have move this one to this side. Then we have 10 equal to what? 81. Call this one equation 1. And then from B to C, it will be this one. From B to C, we're going to have U. Our U will be 30, and our V will be 45. From B to C, and the time in that place from B to C is T2. Okay, that's our time in that place from B to C. Do the same equation also, and make your substitution. That's 45 equal to 30 plus acceleration is not changing. Then move this one to this side. Then we have 15 Then we have 15 equal to what? Equal to 82. Call this one equation 2. Okay. So then divide equation 1 by 2. So if you do that, you're going to have equation 1 10 over 15, 10 over 15, which is 2 over 3 equal to what? Equal to acceleration we cancel, and we have t1 over what? Over t2. And that finished the solution for the A part. We still have the B part, but there's no space. I'm going to write the B part now. Okay, so that's what we have. T1 over T2 is 2 over 3. Okay, and this is what we do. We're given from point A, point B, point C, and we have the respective value for the speed: 20 at point A, 30 at point B, and 45 at point C. Okay, so, and we are told that from A to B, the time is T1. So we're going to make the movement from A to B, okay, and get the initial velocity and the final velocity, which we have done here, and make this 81 the subject. From B to C also, your U will be what? 30, your V will be 45. Do the same thing also, and divide equation 1 by 2. You get the required equation. Okay, we are told to show that T1 over T2 as this. Yeah, the continuations of the questions, given that the total time taken for the particle to move from A to C is 50. The total time taken to move from A to C is 50. Find the distance between A and B. Find the distance between A and B. So what we're going to do in this question, the total time taken for the particle to move from A to C is 50. So that will be total time, that will be T1 plus T2. Okay, T1 plus T2. That's total time taken. And that will be equal to, don't forget we have T1 over T2 equal to 2 over 3. So we can make T2 as a subject. We can make T2 or T1 as a subject. So that will be T2 will be equal to this one times this one. That's 3 over 2 T1. So you can substitute back to this place, which will be T1 plus the T2 is 3 over 2 T1, and the total time is what? From A to C is 50 seconds. Okay, the total time, which is T1 plus T2, is 50. Okay, so we're going to have this one times this one. That's a 2 T1. That's a 5 over 2 T1 equal to 50. Okay, and we can make T1 as a subject, which will be equal to what? 100 over 5, and that's 20 seconds. That's 20 seconds for T1. Okay, that's 20 seconds for T1. You can as well get the T2. Okay, you can get the T2 if necessary. Well, we don't need that. Once you get your T1 as 20, that means T2 is what? T2 is 30. Because the total time is what? Is 50. So we've gotten T1, okay, which is time taken from A to B. Time taken from A to B is what? Is 20. Okay. Okay. So we can, don't forget the time we are given. We are given the speed from A to C as 20 30 and 45, respectively, meter per seconds, meter per seconds, meter per seconds. Okay, so if you're looking for distance between A and B, that means your U is 20 and your V is what? Is 30. Your V is at 30. Okay, meter per seconds. So then we can find the distance between A and B as using this formula. Okay, T1. That's the distance, the time between the time taken from A to B is T1. So your U is what? 20. Your V is what? 30 over 2. The T1 is what? 20. So 2 here 1, 2 here 10. So that's a 50 times 10. That's a 500 meter. And that's the distance between A and B. That's the distance between A and B. If you're yet to subscribe, please do so right now. If you're yet to subscribe, do so right now.